Hi, everyone. We're just going to give it one more minute to see if anyone else shows up. Okay, we have a lot of ground to cover today, so let's get started. So first of all, I want to say thank you so much for joining us today. We're really excited to see how many people have tuned in to get to know Nora, our latest agent in our AI agent lineup. And Nora is going to be here to help you with all your well-planning engineering needs. But before we get started, let me introduce myself. My name is Caroline, and I will be your host for the webinar. And along with me, I have Ji and Tong, and our AI experts who will be giving you all the insights into Nora. I just want to quickly go over some housekeeping items. So we would love all your questions and your discussions, but we will save answering these till the end. So please submit your questions in the Q&A area. You can find the button in the top toolbar, and we'll be monitoring them throughout the webinar, and we'll try to answer as many of them as possible in the actual webinar. But for those that we don't, we will venture to give you written answers and also make the recording and the slide decks available within 24 hours. So quick over the agenda today, we're going to give you a brief introduction into energy AI agents before deep diving into Nora and her use cases. And we have quite a few demos lined up to show you how Nora can help you. And then we'll obviously be doing the Q&A. So taking a brief look at overall energy AI agents. So in 2024, we really saw the birth of the movement into AI agents. And in the year to come, we will see a further shift towards the use of agents across various industries. For us, with our experience and our foundational technology, we see this as an amazing opportunity to develop specialized vertical AI agents within drilling. These agents will revolutionize workflows, and they can be designed for specific tasks and automate processes entirely and work proactively and improve and learn over time. So really delivering a transformative solution and unlocking new possibilities to drive innovation and efficiency. So we have quite an ambitious roadmap of a whole collection of digital colleagues that will be available to enhance your organization. And we will also be making the building blocks available to be built further on or to enhance existing technological investments you might already have made. And we strongly believe that this is actually the digital revolution this industry has been waiting for. So with that, we want to officially introduce you to Nora, one of our first AI agents we will be launching, and I'm going to hand it over to Ji.
Thanks, Carolina. Hello, everyone. My name is Ji. I'm so glad to introduce Nora to you today. Nora is our new well-planning engineer powered by Agentic AI. She seamlessly integrates into existing workflows, working tirelessly 24/7, ensure efficiency, accuracy, and cost effectiveness. Unlike conventional planning tools that require constant human input, Nora actively designs, plans, and optimizes wells while collaborating with engineers as a true AI teammate. Her goal is to remove inefficiencies, automate tedious tasks, and help teams to focus on critical decision-making rather than manual execution. So what is Nora and what does she do? So first of all, Nora is more than just an AI model like an LLM. She's an autonomous AI agent tailored to well engineering, focusing on the designing and planning phase. She reasons, she makes decisions, and interacts with industry standard tools and autonomously optimize well design. She can act as a co-pilot working alongside the engineers to streamline workflows, reduce manual input, and ensure that well designs are as efficient and risk-free as possible. Besides, she can be deployed in the autopilot mode, handling complex engineering calculations and optimizing designs without constant supervision. This shift from manual trial and error to AI-driven optimization is a game changer, allowing engineers to focus on strategics while Nora takes care of the execution. Meanwhile, there is a misconception that AI tools are simply database and chatbot that retrieves and summarize information, or with data-driven machine learning models. Nora is much more than that. She is an intelligent learning machine. Instead of merely storing and recalling data, she learns from a vast amount of well-planning knowledge and applies it dynamically to solve engineering challenges. Nora also acts as a user of apps interacting with engineering applications. She understands how to use tools for casing design, for trajectory planning, for well-controlled evaluation, and even for kill simulation. Engineers no longer need to waste time navigating menus, input coefficients, parameters, running simulations, and wait for the results. Nora does all of this instantly, ensuring optimal designs with minimum human intervention. To explain that in details, I would like to list 5 use cases among Nora's capability extending across a wide range of applications. So first of all, Nora is a domain expert who knows drilling, who knows how to design well. Built upon latest and greatest AI models like a smart person, Nora is further trained with domain knowledge to be a smart drilling person. Nora acts as an always available expert, instantly retrieving relevant information, summarize complex topics, takes care of thousands of reports and summarize for you so that she assists engineers in troubleshooting problems. The second use case is more about the data. Engineers often have to search across multiple systems, document repository, spreadsheets, simulation results, and all kinds of drilling reports just to gather the necessary inputs for well-planning software. Even when they find the data, it's often to inconsistent formats, requiring time-consuming reconstruction and reformatting. Nora, as your data manager, automate this entire process by unifying and interconnecting all relevant well-planning data. She eliminates the need for engineers to manually search for files, for data, rename dataset, or copy-paste numbers across different systems. Instead of spending hours trying to locate and prepare data, engineers can now access structured or unstructured data, usable information instantly, allowing them to work more efficiently. The third use case is about using multiple software tools, ensuring requiring different input parameters, calculations, and iterations. Traditionally, engineers must enter data manually into trajectory planning software, let's say, then run a simulation and wait for the results, analyze the output of the results, and tweak the parameters a bit and repeat the cycle until we get good results. This often takes dozens of times. Every change requires navigating through the menus, click through forms, and waiting for calculations to process. This is tedious and inefficient. Nora, as an efficient user of tools, handles these repetitive tasks. She interacts with well trajectory design, let's use that again, casing design software, and wellbore stability models autonomously, running multiple scenarios in parallel and presenting engineers the final results. Instead of spending hours running those manually, engineers can now rely on Nora to use a variety of tools autonomously, saving various time and reducing human error. Besides that, engineers often need to go through the design process multiple times to optimize the plan, to running a software or a bunch of software in the workflow for many times. For example, in optimizing the drill parameters, we nowadays use trial and error, but Nora doesn't just test one scenario at a time. She runs multiple simulations in parallel, learning from the results and refining the plan autonomously to pursue the goals we set for her, most likely efficiency, safety, and cost. Last but not least, Nora helps with generating all kinds of drilling reports, which usually cost extensive time on manual work. Whether it's daily drilling report, well completion report, or operational reports, engineers typically have to pull data from different resources, formatting it correctly, and ensure consistency before submitting it. Nora eliminates this hassle by automatically generate reports with up-to-date data, accurate information. She pulls information directly from simulation, from database, and from other operational data set, formatting reports to match your company's standard. So these are just 5 examples of a wild variety of capability of Nora. And I guess now you have a pretty clear understanding of what does Nora do with the capabilities. But then let's move to the most exciting part, which is demoing all those use cases in a very specific example so that to understand how it works really with Nora in the planning phase. Next, I would like to give the word to Tom, my colleague.
Thank you, Jie. Hello, everyone. My name is Tom. I'm an AI scientist here in Yizhiling. I'm very excited to show you some use cases of Nora. As Jie mentioned, that Nora was trained on both domain knowledge and loads of internal data within the framework of the company. So Nora can actually work very well as a domain expert in 2 different ways. The first one is that usually within our company, we have some general knowledge from drilling industry or petroleum industry. And when you ask ChatGPT, because ChatGPT is not particularly trained on domain knowledge from drilling industry, so it cannot give you very concise answer. But with Nora, we can generate a very concise answer. For example, here we show one example, what drilling fluid properties that we consider for formation, stability, and hole cleaning. And Nora can give a concise answer here. So this is a general knowledge retrieve function that we show here. And another one is Nora working as a domain expert in terms of internal knowledge retrieval. So let's say every company has their own data and then their own document. They don't want to share this data. So actually with Nora, you can actually build a database or knowledge base that you can directly to extract data or to ask questions from your database. So here we show one example. The question is how to use Well Planner to optimize drilling parameters recommended for operation. So Well Planner is the internal tool, and we feed Nora with this internal document from our company, and you can see that Nora can learn this knowledge very well and return a very concise answer. And the second use case is about Nora working as a data manager. So here, imagine that a drilling engineering in front of him, there will be, as Jia mentioned, they have unstructured data and structured data, and they want to retrieve some useful information, and takes it takes much time for them to do it. So here with Nora, you can actually easily to access your data. You don't have to write this very complex query or use other complex database. All the data are together, so you can just ask Nora to do the data search. Here we just show one example. Can you find mud weight in surface vertical and lateral section of the well A? So this question is very, very in detail. So Nora can return a very concise answer for this. And for the second use case, we have another demo here, which shows Nora can work as a data manager for data restructuring. So imagine a drilling engineer, and he wants a well trajectory configuration file as an input for his software or Microsoft. But the thing is, it takes his time to organize this information to generate a configuration file. But if you tell Nora that the specific template you want to use and the specific task that you want Nora to do, then Nora can return you a perfect trajectory well configuration file for the further input. So yeah, that's the two use cases I'm demonstrating here. Then I will hand over to Jie again. Thank you.
Thanks, Tom. I'll take it back from here because putting the data in the desired format and send it for the software to use is part of the job for many engineers. At least engineers using our software need to do the same before, but not anymore now. Now we just ask Nora to restructure every data we need in the desired data format, like in JSON files for this case using Well Planner, and then I just need to download this and send it to Nora to use the software. So here you have the next user case, like to demonstrate that Nora is a tool user. Here we are using the tool with the well planner. So on the top, you see that I drag the well configuration file in JSON format, which is generated with the help of Nora. I can just drag it here in the chat and ask her to run the simulation with this well configuration. Then Nora did the job and connect through API to the well planner, the software, and ran the simulation and get the results back. The simulation is successful, and I ask, can you show me the plots, the plots from using the software? By the way, the software well planner is a dynamic flow modeling and temperature modeling. We call it DHT modular, to simulate how the fluid and temperature reacts to the drilling plan. So here are the squiggly lines we usually look at, while how each parameter changes along depth if you use those operational parameter. Here, by running the software, Nora directly send me back the results, and of course I can click to see the results and also to go to the API to manipulate the kind of the curve by myself if I want to have it look in a different way. So this is to demonstrate that Nora can use any software as a microservice so easily. But my question is, sometimes I need to run the simulation multiple times. Can I run it simultaneously? Of course, yes, Nora said yes. And here I want to optimize my drilling plan by changing the parameters of ROP, weight down bit, RPM, or flow rate. I can give the specific range, which here I said that can you, based on the JSON file I provided with a different parameter range, and ran a bunch of simulation, which are 50 simulations in this case, and try to optimize the drilling parameters. Of course, Nora said yes, and she used the API and ran the simulation simultaneously and find the results very quickly. You see, this is a list of simulation with the number of 1 to number 50 and how these simulation results looks like. Then I would like to optimize based on those simulation. So like what's the criteria? I would use a scoring system to rank all those simulations based on drilling efficiency, cost effectiveness, and potential risks and hazards, so that I ask Nora to optimize the case. And not only that, I would like to have a report based on all those simulations. So I asked Nora, can you generate a report for me? She did. She gave me a simulation report to summarize all those simulations. This is exactly what I need as an engineer, so that I can further look into the simulations to see whether this is good enough, whether I need to do something else, or whether all of the strategic thinking I should have as an engineer. So this is the whole workflow of first starting from knowledge, data, and then using software, like to show how it works with Nora. Here we put them together in a video in how really we interact with Nora and how it looks like working with Nora in an everyday job of engineer. So here is the interface, which is work with Nora, set as an interactive collaboration workspace. So like today, I want to design the drilling fluid. I need to know what to consider when we design the MARD, drilling MARD. Here are like 9 or 8 parameters that I need to consider. And then I want to know, in terms of the internal documents, how can I optimize the drilling parameters? It gives me the very detailed description. And then I need to know what's the MARD designed in a well, offset well. So I get the reference from offset well, so I can use it in this well. But also, when we want to put this to run simulations, I need to put all the data needed in a specific format, which here is the JSON format as input configuration. I asked Nora to gather everything needed in the JSON file. So she does this and showed me all the details, and then I just need to copy paste or download the file and then send it to Nora again to run the simulation. And here you can see that I asked Nora to run the simulation with the data I sent to her, and now she's running the simulation very quickly because the API, calling API and running the physics-based modeling is so fast, and I get the results. And the results has a quick summary. I want to check the details, so I have the traditional squiggly lines showing here. I can, of course, save this as a figure, or I can go to the API to see how it really looks like for each of the simulation case. Now, in terms of optimizing, like I mentioned in the case study, in the demo case, I want to run a number of simulations so that I can compare them and optimize the operational parameter. So I ask Nora to do all those simulations at the same time. So here is the API. So Nora use OpenAPI to call this microservice and run those simulations at the same time. The results is given instantly, and all the simulation results are shown here as a summarize. Finally, as I said, I want to report demonstrate that so that I can understand how Nora optimized this, or how she ranks each of the simulation, ranks the performance. So I asked her to explain more details to me, like how she can optimize this. What's the considerations she put in optimization? Of course, it's part related to Well Planner because that's the software we're using. It's not something created by Nora, but it's something referring back to the software menu. And here are the list of considerations. So these are the considerations when Nora tried to optimize the operational parameter using Well Planner. And then I asked her, can you recommend me the final operational parameters like for ROP, flow rate, and RPM? And she further explained all those, even the fluid properties. So these are the final recommendations based on the simulation, based on my first design and my a number of simulations of control parameters. So here I got my results. I'm pretty happy with the optimization. And finally, I want to write a report on that. I don't want to put efforts myself, but I asked Nora, can you write a report based on those simulation? Yes, of course, she did that. She gave me a report here. Of course, we can further design the format of the report. So it doesn't need to be limited to a simulation case report, but to daily report as long as we specify the format. So those informations Nora pick from the database, from the simulation results, and put in the report so that I can have a report and share with the colleagues and discuss with the colleagues and see whether that's good enough. If it's good enough, I can send it to my supervisor or send it for training engineers. So this is how it looks like working with Nora. It's really kind of a dream for me as an engineer because a lot of jobs are done by the agent, not myself, especially the tedious works or jobs like gathering data, put them in the software and wait for the results. But meanwhile, I can go for coffee, talk with a colleague, and come back to see the final results. That's really revolutionized how we can use the software, how we can manage the data. But what makes this everything possible, as we mentioned, that depends on the architecture we designed for Nora. So here is the NetMe, how we make this possible. As I said, Nora is working with the engineers from different different roles in different companies, and the interaction is not by providing so many windows, so many software GUI, but just a natural language interaction, very simple, very interactive, but very to the point. So a multimodal interaction will be come later. I should give credit to the big technical companies, not us, because we directly use those technologies developed by them. But we built them upon, we built Nora and other agents upon those technology to make them more customized and suitable for our domain, which is training. Within Nora, behind Nora are three main components. The first one, of course, is the large language model part, which not only can include the large language model, which is deployed on cloud or on premise, but also some orchestration tools like AutoGen, LangGraph, LangChain, and also the infrastructures on the bottom. Here, we're trying to make Nora as a very smart person, but also very smart training engineer that knows everything, knows how to use tools, understands the concepts, understands the fundamentals. This is a huge change from a large language model by itself. But more than that, we have another component which is called Nora reinforcement learning. Reinforcement learning is how Nora can optimize the process without doing it manually. So we have different agents working on different tasks like the casing design, the trajectory design, and also the training parameter optimization. Those sub-agents with specific objectives defined can pursue those goals by running the software, use the tools, finding data, combine everything, but directly feedback the results. The beauty of reinforcement learning is that it can not only give us the results, but also give us the reasons why she reached to the results. So to make the results very trustworthy. On the very bottom is the foundation of everything is the microservices available. Those are especially the physics-based modeling and software that we rely on every day. That makes Nora be trustworthy and provide the reliable resources. And on the left bottom, you see the data storage is isolated from Nora because Nora doesn't need to store any data. She only retrieves it when she needed it to run the simulation or to feedback to the users. This, to our knowledge, best protect the data privacy from any user. That's the anatomy behind that. I'd like to give back words to Carolina.
Thank you so much, Ji and Tong, for giving us such a good overview of Nora and her abilities. As we mentioned, we really want Nora to unlock a new level of efficiency within your organizations. And our vision is that in the future, everyone involved in well planning will have their own Nora companion who can assist and automate tasks. With her abilities to use tools as well as reason and pursue specific goals, we really want to free up time for drilling engineers to focus on more strategic decisions rather than spending hours entering data, running software tools, optimizing drill plans, and generating reports. So we want Nora to do that part for you so you can focus on more value add tasks and decisions. So some of you might be wondering how quickly you can get your hands on Nora. Well, Nora is going to be available for internship in the coming months, where she can already help you with data management, automating the well-designed process, and optimizing drill plans. And over the coming years, she'll continuously learn and gain new skills and become an even more powerful colleague. So if you're interested in hiring Nora, then please don't hesitate to get in touch with us. And now let's answer some questions. So we only have a couple minutes. So I know that we've talked a lot about this actually, G, already, but can you just give a brief summary of what differentiates Nora from the current design software that's available today?
Yeah, a good question. I would like to take that. So engineers usually spend a significant portion of their time searching for relevant information, inputting data into multiple systems because we are using different software from different service provider. We need to reconstructing it to fit for different formats and click through the endless menus in various software tools. So instead of focusing on solving engineering challenges, they often find themselves like what I have been engineers doing is we are so bogged down by manual repetitive tasks. This is why we developed Nora. So Nora steps in and Nora takes over all those tedious but repetitive tasks. And Nora eliminates inefficiency and enables engineer to focus on truly matters like the designing and optimizing part or more strategic thinking. So this is the huge difference from Nora than another design software, I would say.
Yeah, thank you, G. And obviously in the examples that we gave with the demo, we used Well Planner, which is an e-drilling optimization software. But can Nora use other softwares to help design a well?
Yeah, good question, because everyone has a number of software used in planning phase, and those are from different providers. Nora is designed to integrate with all softwares used in planning phase and autonomously operate planning phase and using the software. So the short answer is yes, of course. As for how she used those different softwares, it depends on the compatibility or API access and customization. For example, we used Well Planner in the demo because it's from eDrilling and it's for dynamic modeling of hydraulic and temperatures. It is available as a microservice, so it can be easily, seamlessly accessed and interacted with any agents like Nora. So Nora can run that very easily and can run the simulations simultaneously. But if the software is only available as a desktop version, without the microservice option, then we need to do some customization, like to develop adapters so that we can use the software.
Perfect.
Yeah,
Thank
good
you. I
question.
see that, yeah, I see that we're out of time. So like I mentioned already, for anyone who didn't get their questions answered, we will venture to answer them in written format if you've submitted them. If not, please submit them now before you leave the meeting, or you can also get in touch with us on LinkedIn or via email, and we'll obviously answer those questions. And as I also said, we will make both the recording and the slide deck available within 24 hours and send it out to all of you so you can look, review in your own time, look at it again, or even share internally with your colleagues. So with that, I want to say thank you so much for tuning in. We are really excited to bring Nora into the world. So thank you so much.
Thank you all.